Before AI could speak, before it could write, before it could answer your questions, before it could create images, and before it could sound almost human, it needed something hidden. Not a face, not a voice, not a robot, not even a human mind. It needed power. Quiet power. Hidden power. The kind of power that works behind the screen, behind the words, behind the answers. A machine behind the machine. A force most people never see, but almost every modern AI system depends on. And for years, one company was building that power. Not for AI, not at first, but for games, for pixels, for light, for images moving across a screen. That company was NVIDIA. And this is the strange story of how a company built for gaming became one of the most important forces behind the age of AI. Today, when people talk about AI, they usually talk about the visible names: ChatGPT, OpenAI, Google, Microsoft, Meta, robots, apps, models. But behind the screen, behind the words, behind the answers, there is another story. A quieter story. A story about chips, about heat, about electricity, about billions of calculations happening at the same time. Because AI does not become intelligent by magic. It must be trained. It must read. It must compare. It must repeat. It must make mistakes again and again until patterns begin to appear. And training an AI model requires enormous computation, more than a normal computer can comfortably handle. So the real question becomes, what kind of machine can teach another machine to think? For many years, the answer was hiding inside the world of video games. In 1993, 3 engineers started a company. Jensen Huang, Chris Malachowski, Curtis Preem. They were not trying to build the brain of AI. Not yet. They were trying to solve a different problem: computer graphics. At that time, personal computers were becoming more common, but they were still limited. They could calculate, they could process words, they could handle spreadsheets, but they were not yet good at creating rich visual worlds. Games were changing. People wanted movement, depth, light, shadows, speed. They wanted computers to stop looking like machines and start feeling like worlds. That was NVIDIA's first door. Not intelligence, imagination. The early years were not easy. NVIDIA did not begin as a giant. It began as a bet, a risky bet, a belief that graphics would become central to the future of computing. But the future is never obvious when it is still small. At the beginning, NVIDIA struggled. Its first products did not immediately turn the company into a legend. The market was crowded. Competition was brutal. And in technology, being early does not always mean being right. Sometimes a company can have a powerful idea, but the world is not ready for it, or the product is too complex, or too expensive, or simply not what people need at that moment. That is one of the quiet lessons of NVIDIA's story. A great future can begin with failure. But NVIDIA kept moving. It listened, it changed, it adapted, and slowly it found the idea that would define its future: the GPU, the graphics processing unit. To understand why this mattered, imagine 2 different workers. The first worker is very fast, very intelligent, very good at making decisions one step at a time. That is like a CPU, a central processing unit. The second worker is different. It may not think about one task as deeply, but it can do thousands of small tasks at the same time. That is like a GPU. And graphics need that kind of worker. A screen is made of many pixels. Each pixel needs color, light, shadow, movement. Instead of doing one calculation after another, a GPU can work on many calculations in parallel. This was perfect for games. But later, the world would discover something bigger. Parallel processing was not only useful for drawing images, it was useful for training intelligence. In 1999, NVIDIA introduced the GeForce 256. It helped popularize the idea of the GPU as a separate force inside computing. At the time, many people saw it as a gaming breakthrough. Better graphics, smoother worlds, faster movement, more realistic games. And that was true. But hidden inside this gaming technology, there was a deeper possibility. A GPU was not just drawing images. It was proving that computers could work differently. Not only faster in one direction, but wider, more parallel, more like a crowd of workers moving together. That idea would become one of the foundations of modern AI. But in 1999, almost nobody saw the full picture yet. Sometimes the future hides inside something that looks like entertainment. Then came one of NVIDIA's most important decisions. A decision that did not look exciting to ordinary people. It was not a game, it was not a screen, it was not a beautiful image. It was software. CUDA. In 2006, NVIDIA introduced CUDA, a platform that allowed developers to use GPUs for more than graphics. This was a turning point. Because before that, a GPU was mostly seen as a tool for visuals, a tool for games, a tool for rendering. But CUDA opened a new door. It told programmers, you can use this power for other problems too. Science, medicine, physics, engineering, data, and eventually, AI. This is where NVIDIA stopped being only a graphics company. It became a computing company. And that difference changed everything. At first, not everyone understood the importance. That is common with ideas that arrive too early. Some technologies do not explode immediately. They wait. They wait for the right problem. They wait for the right moment. They wait for the world to become ready. For NVIDIA, that moment came when AI needed more power. AI models were becoming larger. Researchers were training systems to recognize images, to process language, to detect patterns, to learn from massive amounts of data. And suddenly, the old way of computing was not enough. The world needed parallel power. The world needed GPUs. The same kind of technology that made games look more realistic could now help machines recognize the world. A tool built for pixels became a tool for patterns. This is the strange beauty of technology. A thing created for one purpose can become powerful for something completely different. The GPU was born to make images move, but AI needed something similar. It needed to process huge amounts of data at the same time. It needed to compare patterns across millions, then billions, then trillions of examples. And the GPU was ready. Not because NVIDIA predicted everything perfectly, No company does. But because NVIDIA had spent decades building the kind of power that the AI age would eventually demand. That is why some companies do not simply follow the future. They accidentally prepare for it. And when the future finally arrives, they are already standing in the right place. Then came the AI boom. Suddenly, AI was no longer only a research field. It became a global obsession. People were talking to chatbots. Companies were building AI tools. Students were using AI to study. Designers were using AI to create. Programmers were using AI to write code. Businesses began asking how AI could change everything. And behind many of these systems, there were NVIDIA chips. Not always visible, not always mentioned, but essential. Like electricity in a city. You may not think about it every second, but the entire system depends on it. NVIDIA became part of the hidden infrastructure of the AI world. Not the app you open, not the answer you read, but the power behind the answer. This is why NVIDIA's story became so unusual. For years, many people thought of it as a gaming company, a company for gamers, for graphics cards, for people who wanted better performance on their computers. But by the mid-2020s, the center of the story had changed. Data centers became the heart of NVIDIA's growth. The company was no longer only selling chips for people playing games. It was helping build the factories of intelligence. And these factories do not look like old factories. They do not have smoke coming from chimneys. They do not produce cars or steel or clothing. They produce computation. They produce training. They produce models. They produce the hidden work that makes AI possible. In the industrial age, power came from engines. In the AI age, power comes from computation. And NVIDIA became one of the companies closest to that power. But power always creates a question. If one company becomes central to the machines that train AI, what does that mean? Is NVIDIA only a supplier? Or is it becoming something deeper, a gatekeeper, a foundation, a company that does not control what AI says, but helps decide how fast AI can grow? This is why NVIDIA matters. Not only because it became valuable, not only because its chips are powerful, but because it sits near the center of one of the biggest transformations in modern history. AI needs data. AI needs models. AI needs researchers. AI needs software. But it also needs hardware. It needs physical machines. It needs chips made from silicon. It needs electricity. It needs cooling. It needs factories. This is the part of AI that many people forget. AI may feel like something floating inside the cloud, but the cloud is not magic. It is buildings, servers, chips, cables, heat, energy. And inside that physical world, NVIDIA became one of the most important names. There is another lesson here. NVIDIA did not become powerful only because it made a good chip. Hardware alone is not enough. The real strength was the ecosystem, the chips, the software, the tools, the developers. CUDA, libraries, systems, a whole world built around the GPU. This is very important because in technology, the strongest company is not always the one with the best product alone. Sometimes it is the company that builds the environment everyone else learns to live inside, like a language. Once enough people speak it, it becomes harder to leave. NVIDIA did not only sell hardware, It helped build a language for accelerated computing. And when AI needed acceleration, that language was already there. But no empire in technology is completely safe. Every powerful company creates competitors. Every success invites pressure. Other chip companies want a piece of the AI future. Big technology companies are designing their own chips. Governments worry about who gets access to the most powerful processors. Export restrictions turn chips into political tools. And the world begins to understand that AI is not only a software race, it is a hardware race, a supply chain race, a national strategy race. The future of AI does not depend only on ideas. It depends on who can build the machines that make those ideas possible. And that makes NVIDIA's position both powerful and vulnerable. This is the quiet tension inside NVIDIA's story. The company helped build the foundation of the AI age, but the more important it becomes, the more pressure surrounds it. Customers depend on it. Competitors chase it. Governments watch it. Investors expect miracles from it. And the world keeps asking for more power, more chips, more speed, more intelligence, more everything. That is a heavy position for any company, because when a company becomes part of the future, it also becomes responsible for part of the future's uncertainty. And maybe this is what makes NVIDIA's story so interesting. It is not only a story about money. It is not only a story about graphics cards. It is not only a story about AI. It is a story about timing, about patience, about building something for one world and watching it become essential to another. A company started with games. Then it helped science. Then it helped data. Then it helped AI. And now it helps build machines that may change work, education, medicine, creativity, war, business, and the way humans think about intelligence itself. So the next time you use an AI tool, the next time a machine writes an answer, creates an image, summarizes a document, or helps someone solve a problem, remember this. Behind the intelligence, there is infrastructure. Behind the words, there are calculations. Behind the cloud, there are machines. And behind many of those machines, there is a company that began by trying to make games look better. That is the strange path of NVIDIA. From pixels to power, from games to intelligence, from graphics to the hidden engine of the AI age. And maybe the biggest question is no longer, can machines think? Maybe the question is, who builds the machines that teach them how?